All right, in example 3, which is last example in 10.2, it gives us another one of those real situations where it's talking about some hockey team owner wants to boost fan support, and so he decides to change the ticket prices. And if you looked at that function, T of G is equal to 10 minus 0.1 G, it has a negative slope, so the ticket price is decreasing. And then later on in A, it wants us to determine R of G, which is equal to T of G times A of G, and explain what it represents. Well, let's write it out because I think that can really help. And you might know what it is already. I'm going to use a capital R. I'm not sure why they don't. So I'm going to say that R of G is equal to T of G, and I'll use that closed dot so we get used to it, times A of G. And I'd like to just point out that this is the ticket price, and this is the attendance, which is just another way of saying, the number of tickets. So if I take the number of tickets and multiply them by the ticket price, what I get is revenue. So this is how much money the owner of the stadium, or I guess the shareholders of the stadium, are actually bringing in as people go to these games. Now they want us to actually determine the function. So R of G is going to be equal to 10 minus 0.1 G times the attendance, which is given to us as 8 plus 0.2 G. All right, now to truly deal with that function, we are going to have to look at the graph of it. I have that present on the other page here. That's this guy right here. Now, the part B there, I'll just go, it wants us to use the graph to determine where the owner increases or decreases revenue from the ticket sales. So originally he's making, I don't know, give or take $90. But then it starts to go up. Keep in mind that this is revenue. So the amount of money he starts to make goes up and up and up until he gets to the 30th game. That maximum will be at 30,98. So 98 is going to be the biggest amount, or the biggest amount of money he makes. I'm just going to look. So A is in hundreds. So we are talking about hundreds of dollars. So that's $9,800 from 3,000 people or 3,000 people. When we look at that point, it basically means that if G is less than 30, revenue is increasing. If G is greater than 30, revenue, I spell revenue wrong? Revenue, there we go, is decreasing. And that is the idea that maybe the owner of the stadium doesn't care because he thinks he's getting more kind of long-term loyal patrons or fans. But at some point he might consider, okay, we're gonna change the price until the 30th game, and then we're gonna keep it steady and hope that we brought in enough people to keep making money. All right, the next part of this question talks about two different functions. So C wants us to develop an algebraic and a graphical model for P of G is equal to N of G over A of G. Now, they throw a lot of different functions at us. I'm just going to identify, so I don't forget, it's 2 minus 0.05 G divided by A of G, which was our 8 plus 0.2 G. Now, in the question, it tells us that N of G is the number of free noisemakers. So number of free, and I'll just put devices. I don't know what kind of noisemaker it is. Could be a Vuvuzela from the World Cup a few years ago. So it's the number of free devices over the attendance. Now, we don't do a lot of this in Dash 1 Math, but if you look at, and ultimately what that is that the favorable outcomes over the total outcomes, right? We want to get a free noisemaker, but if there's only 4 available for 10 people, then I realistically have a 40% shot at it. So what this P of G is it's the decimal chance of getting a noisemaker. Now, if we want to look at, a graphical model of that function, we could type it into our calculator. What they really want us to do here, though, is it says, what is the chance of receiving a free noisemaker for a fan attending game 4? Keep in mind that we've identified that P of G is that chance. So what they really want us to find is P of 4. So that's going to be 2 minus 0.05 times 4 over 8 plus 0.2 times 4. That gives me 2 minus 0.2 divided by 8 plus 0.8, which is 1.8 over 8.8. Or if we grab our calculators, because that's really what we want, right? Nobody wants that chance of winning a noisemaker as the fraction. But if I take 1.8 divided by 8.8, what I get is 0.2045, and it goes on forever. So there's a 20% chance that we get that free noisemaker in the fourth game. Looking at those two different functions, because the number of noisemakers is going down, the attendance is going up, our chances of getting a noisemaker are going to go down and down and down as we go throughout the season. All right, yet again, there's the non-modified or original textbook assignment there. Check Google Classroom because we are modifying these as we go.